Please respond in chat box. Am I audible and can you see me clearly? Please respond. Can you see me? And am I audible clearly? Please say yes or no. Yes. Okay, so I'm happy to see you all again, and I'm seeing the old names which came here when I was taking the course on engineering mathematics. And of course, I enjoyed teaching that course with you, and I hope you also enjoyed the classes. So anyhow, we are back again with the revision and the PYQ series of engineering mathematics. And GATE is too short, as we discussed yesterday, and our main intention at this point of time is to know the approach of solving the questions actually. Correct. So yesterday I have already given you the schedule regarding how we are going to progress in this course, and obviously today itself we are starting this course as mentioned yesterday, and the first topic that we are going to deal is concepts of limit. So straight away, before going into the concepts of this limits, we shall divide the syllabus, and of course you already have the schedule, but I just wanted to give you the outline how this course goes on for the people who didn't attend yesterday. Okay, so coming to the things, of course, it's a revision and PYQ session. So complete mathematics, it comes around for 13 to 15 marks. It's known to us. So we are going to divide this 13 to 15 marks in this fashion. So if you see, we'll be starting with calculus, and where this calculus, we have the majority of the content that is to be covered, and we'll start with basic calculus. Okay. And next, once we finish the basic calculus of both one variable and two variable, then we'll move on to differential equations, because by this time you will be knowing how to find the derivatives, and you can solve a few differential equations at this moment. Okay, and once we finish this differential equations, then we move on to something called access in geometry, which is called the vector calculus, which is of most important for many of the core branches. Vector calculus, and then we'll go for something called complex calculus. Got it? So we go for these 4 submodules in this calculus, and again, of course, as you have seen yesterday, these topics are again divided into subtopics, so that we can have a clear idea on each and every type of question that appears in GATE. Okay, so this calculus holds the majority portion of the syllabus, and it takes, of course, most of the time that we use here in discussing the things. And next, once this calculus is done, and of course I would like to name it as 1, and second we go to something called linear algebra, where we deal with a lot of matrices and basically system of equations, rank and all, where questions are most frequent in GATE examination. So we deal there, and then we go for something called one of the most interesting chapter and the easiest chapter, probability and statistics. Where we'll be working out very good questions actually. And of course, in this probability and statistics, I'm going to spend some more time, because many of you who might not attend my previous course on engineering mathematics might come here. So I just wanted to brief you definitions and all again. Okay, so we'll spend some more time here, and then we'll go for one very good topic called numerical methods. And please trust me, whoever feels this numerical methods is a formula based chapter and all, I have already proven that it's wrong intuition. Correct? Many people who have attended already this engineering mathematics course by me, they know how each and every formula gets evolved in this numerical methods. Correct? Did you all, whoever attended my previous sessions, can you all tell me, is this numerical methods a chapter of formulas, or do it have some logic? Please tell me, is it a chapter of formulas or no? All of you. There are many people, Kamaluddin and all. Correct? It's full of logic. We have derived each and everything geometrically, and we have shown there. Correct? Yeah, no. Thank you all. And finally, we go for a bit of transform theory. And of course, we are not dealing Fourier transforms, but we deal till Laplace transforms. Okay, transform theory. And if there are a few individual topics, means syllabus is vast, and the topics are not common for all the branches. There are a few individual topics for different branches, and of course we deal them at the end of the course. Okay, so this is how we come up with this course with around 6 modules, and of course each module is again divided into subtopics which is known to you. Clear so far? Can we now start with this first part? All of you, can we start with this first part? Please reply yes or no. Yes? Okay, so before straight away starting the first part, I just wanted to give you a few key points regarding this course. First thing, this course is not a comprehensive course, means I won't be dealing any derivations or some lengthy equations and all, basically, because that was already done in my earlier engineering mathematics course. So if you have any doubt at some point, means how this point got evolved or something like that, you can visit the corresponding video in that course. That full course is available in the same YouTube channel of Engineers Hub, which you can see. It's for open access. Okay. And next, coming to the things, every time, we'll try to go for the approach on how to solve the question. Okay. It's not like we'll substitute this formula and we'll get this answer and all. We'll see the approach, how we are approaching for the solution of a particular question. Okay. That is one particular thing. And third thing, as I told you, in GATE examination, many times it's most important to you whether you can solve the question or not. Okay. Irrespective of the knowledge that you have on the topic. Okay. Sometimes, even if you don't have enough knowledge on that topic, you still will be able to solve the question if you use, a little senses over there. And mathematics is really a good subject, so that if you know all the concepts of mathematics, you will be able to solve even your technical questions. That could help you out. Okay. So this course is really useful for you. And whoever is new here, please don't get panicked, because I have mentioned I'll be revising the things before I start solving previous year questions. Okay. So, but not in a comprehensive way, but I'll let you know how things are going on. Clear? Is that clear to all of you? Can we start now? Okay. So see here. First, we'll start with basic calculus. And the starting point of this basic calculus is limits. And that's how we named this lecture as concept of limits. So what is a limit? Could any of you tell me what is a limit? What is a limit? What is a limit? It's a boundary. Okay. Okay. So let me help you out in a short way. You have seen these kind of expressions in your life. Limit x tends to a, f of x is equal to L, correct? You have seen this. Now, what's the meaning of this equation? This is one equation. You have something on the left hand side and also something on the right hand side. So what is this? What does this equation basically represent? Which means this equation tells us as x tends to a, this symbol is for tends to, and I told you clearly in my basic course that x tends to a and x is equal to a. Both are not same. Okay, these two are not same, because you know the clear distinction. I cannot write 2 into 0 is equal to 3 into 0, and I can't cancel these two zeros. Correct? I can't cancel those two zeros, because we can't, division by 0 is not possible. Correct? Which means, but you have seen some limits like this. Limit x tends to 2, x minus 2 into x plus 2 divided by x minus 2. You have seen such kind of limits in your life, and you have seen these things gets cancelled here. And here, if there are two zeros, you can't cancel. But in limits, if you are cancelling these two terms, which means one thing is very clear, this x minus 2 is not equal to 0. Correct? Yes or no? Please tell me, if I am cancelling this x minus 2 both on numerator and denominator, can I write this x minus 2 is not equal to 0? Yes or no? Please tell me, all of you. Yes or no? All of you, please respond. Whoever is on live. Yes. So if you are able to write like this, which means x is not equal to 2. Correct? Which means when your x is tending to 2, means if you put this right-sided arrow mark, that implies this is not equal to a, which means these two are not same. Clear? And this gives us the concept of neighborhood. So let me quickly tell you what is the concept of neighborhood. Okay. So for example, if you take a real axis, if this is x is equal to a, and x is equal to a minus 1 is so far from there, and x is equal to a plus 1 is also so far from there. Okay. Then if you see small set of real numbers, means for example, let me write here. If I consider this interval, between any two real numbers, there are infinitely many real numbers. Correct? Means between a minus 1 and a, there are infinitely many real numbers, which means there will be some set of real numbers here which are very close to this a. Correct? There are some set of real numbers which are very close to this a, which means there comes some set of real numbers. For example, if I call this difference as delta and this difference as also delta, then this value is a minus delta and this value is a plus delta. Correct? Because this white line is x is equal to a, and if this distance is delta, then the value of x on this line is x is equal to a minus delta. Similarly, here it's x is equal to a plus delta. And the set of real numbers between this are said to be neighbors. What's the meaning of a neighbor? Who stays close to you, correct? And these real numbers are exactly doing the same by lying close to a, which means I can call x belongs to a minus delta comma a plus delta. You know, this is an open interval which includes all the values of x between these two limits. I mean, these two limits, a minus delta and a plus delta. So this values of x or this interval is called neighborhood of a. Neighborhood of a. Okay, because the values which are lying in this interval are very close to a and they are neighbors of a. So this interval, and whenever you are writing x is tending to a, this implies x belongs to, okay, let me write, x belongs to a minus delta comma a plus delta minus, you'll subtract this a. Okay, you know, from this set of elements, which means from this interval, if you subtract this a, then this is the interval that is available with you, correct? And this interval is called dilated neighborhood of a. Dilated neighborhood of a. Why I'm telling you this concept? This concept is really important because to understand the concept of limits, you need to understand the concept of this dilated neighborhood of a. Now, did you all understand what is dilated neighborhood of a? This is called dilated neighborhood of a because we are deleting this a. From this set, we are subtracting this. I'm sorry, this arrow mark. This arrow, it should be closed interval. Okay, fine. So did you all understand what is dilated neighborhood? Because we are subtracting this a from this. Clear to all of you? Yes or no? Please respond. See, I can't see your faces because it's an online class. So please respond. Okay. Correct? So now see here. Whenever you are telling x is tending to a, this says x is moving towards a. X is moving towards a. Okay, this is the meaning of this. If you see this statement anywhere, x with a right-handed arrow towards a, this means this x is moving towards this a. And if x is moving towards this a, then it can happen in two ways. Look, what are the two ways? Look, I'll be telling you out. This is 0. I mean, the origin basically, this is x-axis. Yeah, this is x-axis and this is y-axis. And let us suppose you have a curve something like this, some random curve. Y is equal to f of x. Okay, this is just a graph. So please, you know, it's a common graph. Y is equal to f of x can be any function. We are not defining it at the moment. So please see here. And this line, for example, let me change the color. And this line, for example, is x is equal to a. Okay, now let us suppose there is one value called L here. And this L doesn't have any interconnection with this f of x, correct? This L is just a real number on y-axis, that's it. This L and this f of x are not related in any way. Clear? Is that okay? Is that understandable to all of you as of now? Please tell me. This L and this f of x are not interlinked. Clear? This L is just a value on y-axis. Now, what happens? Let us see here. Now, let us assume that this is your a minus delta. If this is the curve y is equal to f of x, then what can be this value? Please tell me. This is f of x, correct? Corresponding to this a minus delta. Now, if you come to this point, x tends to a. If x is moving towards a, let us suppose initially your x is here at this point. Now, if it's moving towards a, means here, let us suppose it moved here. Then, this is your new f of x, correct? Means by the time x is moving towards a, this f of x has got raised a bit up. Now still if you move your x towards a, means some point here, then this is your f of x, which means you understood one thing. If your x is moving towards a, your f of x is moving towards L. Clear? Did you all understand this point or not? Whenever your x is moving towards a, this f of x is moving towards L. Clear so far? To all of you? Similarly, you can ask me another way. Sir, you are taking from left hand side. Why not from right hand side? Yes, you can take. For example, if this is a plus delta over here, then this value is f of x. Correct? Now, if you start moving your x towards a in this direction, For example, initially the x is here, so let me take a point here. So if I take this point like this, then this will be your f of x. Similarly, if you move a bit closer towards here, then you know this will be your f of x. So it doesn't matter from which direction x is moving towards a, but always your f of x will start moving towards L. Did you understand what's the definition of limit? Means as x tends to a, if f of x tends to L, then this statement mathematically it is written as limit x tends to a, f of x is equal to L. Okay, and this statement says us when x is moving towards a, this f of x which is here will start moving towards L. This is the definition of the limit. Is this clear to all of you? Did you all understand the concept of limit? Please tell me. All of you. Please say yes or no. I want your responses. Okay. Now, with this, the concept of limit gives rise to the concept of left hand limit, and right hand limit. Now, see carefully. Because during the definition of this limit, I didn't mention the direction, correct? X can be in the right neighborhood and it can approach towards left, or x can be in the left neighborhood and it can move towards right. Anything can happen. So, which means we generally denote this as limit x tends to a minus for the left hand limit, which means in bracket you can write x tends to a minus implies x is less than a because it's in the left neighborhood of a, correct? You know, when x is in the left neighborhood, see this is total neighborhood, so this is left neighborhood, a minus delta to a, and a to a plus delta is called right neighborhood. Now, if x is lying in the left neighborhood, then you know by default x is less than a, correct? So that's why we denote with a minus sign. Please be careful, all the students, please be careful. In exam, whenever you're asked to calculate left hand limit, I have seen many people, instead of substituting this, they substitute this. Okay, both are very much different. Please don't, put together in the exams. Clear? For example, see here, if this is a, this is origin, then minus a will be somewhere here. Okay, but a minus will be somewhere here. Clear? This is minus a. A minus is somewhere here. Did you all understand the difference between these two? A minus and minus a. Is that clear to all of you? Please say, did you all, because this difference has to be understood clearly. Okay, otherwise in exam you'll be substituting one for other. Okay, so now if that is fine, so this gives you the value of left hand limit. Similarly for right hand limit, we denote it with limit x tends to a plus f of x. Now, during the definition of limit, I just told you when x is moving towards a, this f of x should move towards L, but I didn't specify the direction, which means if I'm calculating left hand limit and if I'm getting L1, and if I calculate right hand limit, if I'm getting L2, for limit x tends to a, f of x to exist, can you tell me what should happen here? Can anyone tell me what should happen here? If you are calculating left hand limit and if you are getting L1, and if you are calculating right hand limit and if you are getting L2, for the limit to exist, can you tell me the condition? What should happen here? All of you. I want responses from all of you. Please respond. L1 is equal to L2. Because I told you, I didn't specify direction here. So whatever the direction you calculate, you should get the same value L, which means this L1 should be equal to L, should be equal to L. Okay. Yeah, L1 is equal to L2. Both should be equal. Okay, clear. So now, this is the concept of limit. And since we didn't specify the direction when defining the definition of limit, we therefore calculate two limits, the left hand limit and right hand limit. And depending upon this x tends to a minus, we modify this function in problems. And similarly, depending upon this x tends to a plus, we modify this function f of x. Okay. So clear so far? Okay. So we know how to calculate general limits. So now we'll see a few special cases. Okay. So straight away, I'm not solving very simple questions and we are going for some special cases. We deal with one particular rule called L'Hospital's rule. L'Hospital's rule. Let us see what is this L'Hospital's rule. Okay, if limit x tends to a, f of x by g of x is getting 0 by 0 or infinity by infinity form. And remember, you can apply L'Hospital only in these two cases, either 0 by 0 or infinity by infinity. Then limit x tends to a, f of x by g of x is equal to limit x tends to a, f dash of x divided by g dash of x, where this dash, a single dash on the top of the function, represents the first derivative of this function. Okay, please, many people here, they'll be committing mistakes. They'll be writing this formula, derivative of, since this is a division, I hope you know these things. So many people will be applying this u by v rule. No, this is wrong. Okay, you should differentiate individually. Correct? This is f dash of x and this is g dash of x, but you should not apply this u by v rule here. Okay, please don't lose marks, because I have seen students committing this mistake and they are losing marks. Okay, so please don't commit this mistake whenever you are applying L'Hospital's rule. Okay, so please, when I'm telling you don't do this or don't do this, you please make a note over there of your interest. Okay, because in exams that's going to help you first. Might not be initially, but at later when we deal with some complicated chapters, that could help you out. Okay, because in exam we should know what to substitute in formula exactly. Clear? So, but the condition is this should not be 0 by 0. Again, if this is also 0 by 0 or infinity by infinity, you can write maybe or infinity by infinity. If this is also 0 by 0 or infinity by infinity, then we go for second derivative, f double dash of x by g double dash of x, if limit x tends to a, f dash of x by g dash of x is 0 by 0 or infinity by infinity. Correct? If it's not 0 by 0 or infinity by infinity, you can get the answer. Okay, so again, suppose if this value is also 0 by 0 or infinity by infinity, you will differentiate one more time. Yeah, examples, I have put some 20 previous questions which includes all these concepts, so please don't worry about examples. Okay, for your hint, I am giving you one example here which you will be getting 0 by 0 form if you substitute. Okay, anyhow, we'll go to the problems in a short time, but don't worry, I have made good questions. I mean, of course, those are previous gate questions, but we put good questions on slides so that our concepts will be clear. Okay, can I move ahead? And don't worry about this PDF. You will be getting this PDF in the Telegram group that we mentioned yesterday. And don't worry, the links for the Telegram group will be mentioning again at the end of this lecture. Okay, clear? Clear so far? Okay, so if that's clear, this is called L'Hospital's rule. And suppose if this is also 0 by 0, what we should do? Can anyone suggest me? Suppose if this value is also 0 by 0 or infinity by infinity, what can I do? Again, we should find differentiation, correct? Again, we'll get limit x tends to a triple derivative, f triple dash of x divided by g triple dash of x, and this process goes on. So this is one way. Next, we talk about some other indeterminate forms. Of course, 0 by 0 and infinity by infinity is also an indeterminate form, and we have seen one particular method called L'Hospital's rule in solving the questions. So we'll see what's the procedure for the rest of the indeterminate forms. Indeterminate forms. Indeterminate forms. And what are the indeterminate forms? For which the values are not determined or not defined. So if you see 0 by 0, infinity by infinity, infinity power 0, infinity minus infinity, 1 power infinity, all this basically. Okay, so if you keep on writing, okay, so if you keep on writing, there will be a lot of things like this. So we have seen what's the case if we get indeterminate forms of this case. But if you are getting indeterminate forms of powers, for example, you are getting infinity power 0 or 0 power 0, things like that, things like this, then let us see what to do. See, this problem is this, particular concept which we are teaching now is really important, and majority of the gate questions, they frame such that when you substitute the limit directly, you will be getting either this or this or this. Okay, so or infinity power 0, 0 power infinity, 1 power infinity, and all these things. So please take this into consideration. So limit x tends to a, f of x power g of x is an indeterminate form of 1 power infinity, or infinity power 0, or maybe 0 power infinity, things like this, then your approach should be something like this. Let y is equal to f of x power g of x. I'm telling you the approach because if I keep on giving formulas, there will be n number of formulas for this particular form. So I'm telling you the approach. There's only one method to solve this, and if you apply that method, you'll be getting solutions for any of the problems of this particular format. Clear? So if I give you formulas, there'll be a bunch of formulas, but it's really hard for you to remember. And trust me, in GATE exam, please don't go with formulas if you remember, because if you substitute something wrong in that, that's it, your marks are gone. So always try to learn the approaches. Okay, and any GATE problem, if you follow the correct approach, it will get solved within 3 minutes definitely, because they plan in such a way that 65 questions are to be solved in 180 minutes. Okay, so please solve this. Now apply log on both sides. Log y to the base e is equal to, if I apply log here, can I get g of x into ln f of x here? Correct? This is log y to the base e is log of this thing, and ln a power n to the base x is nothing but n into ln a to the base x. You know this. Correct? So if you know this, this can be written in this way. So the third step is apply limits. Limit x tends to a log y to the base e is equal to limit x tends to a g of x into ln f of x. And now let us see. Suppose if you are getting infinity power 0 or 0 power infinity and all, now this will be, for example, let me tell you, this is of the form 0 power or infinity power 0. For example, this is one undeterminate form, which means whenever you are substituting a, this is getting converted to infinity, and this g of x is getting converted to 0, which means the term which is infinity power 0 will come here as 0 into infinity, correct? Which is also an indeterminate form, because whenever you are substituting this a, this g of x is becoming 0, and this ln infinity is again infinity. So if you can convert this 0 into something like limit x tends to a, I can write this as ln f of x divided by 1 by g of x, for example. If I write like this, then this is infinity, and 1 by 0 will also be infinity, and you'll be getting some infinity by infinity form here, for which you can apply L'Hospital rule. Clear? So if there are power forms, for 1 power infinity, there is one shortcut. I'll definitely tell you that. Please wait. But if you are getting something like infinity power 0 or something like this, then log 1 is 0, and this is infinity. A 0 by 0 form you will be getting. Clear? See, you are asking what if this is 1 power infinity? Log f of x is 1, which means log 1 will be 0. And if this is infinity, 1 by infinity is also 0. You will be getting 0 by 0 form. Clear? It's log to the base e or ln. Both are same. Ln or log to the base e. Both are equivalent. Okay, so no issues. So here you will be getting either 0 by 0s or infinity by infinities. So we can apply L'Hospital at this moment. So if you are getting indeterminate forms in terms of powers, like for example, infinity power 0, 0 power infinity, 1 power infinity, and all these things, please apply 2 L's. One L is logarithm, and second L is L'Hospital rule. If you apply these 2 L's, you will be getting the answers for each and every question. Okay. Clear to all of you? Of course, we'll work out few examples on this. It's okay. I want responses from all of you. Please respond. Yeah, I know I'm going a bit fast, but yes, of course, this is a revision class. We need to go like this because we need to spend some qualitative time on solving problems here. Okay. Okay. So if that's fine, we'll go for solving few questions. So let us start this question, and this is in GATE 2012. It was asked in 2 branches same year, mechanical and production engineering. So limit x tends to 0, 1 minus cos x divided by x square. So please try to solve this question. If you substitute 0, you'll be getting 0 by 0 straight away, so you can apply L'Hospital. So please try to do this. Answer is B. Of course, it's okay. Fine. Answer is B. Good. I'm happy that all of you are answering it correctly. Yes, answer is 0.5. See, I'll tell you one limit here. Please try to understand. because this limit can be standardized. See here, limit x tends to 0, 1 minus cos ax divided by x square. If you have this limit here, limit x tends to 0, 1 minus cos ax divided by x square. Look, if you substitute this x is equal to 0 straight away, you know, if you substitute the 0 here, a into 0 is 0 and cos 0 is 1, 1 minus 1 will be 0. Similarly, for x square, if you substitute this 0 here, this will also be 0. So you got 0 by 0 form, which means, yeah, I'm explaining, of course, I'll explain. I don't skip any question. I'll solve all the questions here, what I am putting on PPT, and later we'll be sharing this document to you on the Telegram group. Okay, so no issues. See here. If you are substituting this 0 directly, you are getting 0 by 0. So this means you can apply L'Hospital's rule. So if you apply L'Hospital rule for the numerator, the derivative of derivative of any constant basically is 0 minus differentiation of this cos ax is minus sin ax into the inner derivative of this is differentiation of ax is a. This is what you have, correct? Divided by 2x, which means this is equal to limit x tends to 0, minus into minus is plus, and this a is a constant. So we have a by 2 into sin ax divided by x. This is what you have. So this a by 2 can be taken out as a constant into limit x tends to 0, sin ax divided by x. And this is equal to, again, if you substitute 0 here, sin 0 is 0 and this denominator is also 0. So which means you can apply L'Hospital again for this part of the limit. So a by 2 into limit x tends to 0 into, limit x tends to 0 operating on differentiation of sin ax is cos ax into the inner differentiation of this ax is a divided by differentiation of x with respect to x is 1. So denominator is 1, no issue. A by 2, of course this a is a constant, so I am multiplying this a with this a and I am writing a square by 2 into limit x tends to 0, cos ax will be there here. So if you put x is equal to 0, this value is 0 and cos 0 is 1. So this value is 1. So a square by 2 is the answer for this. Okay. So the answer for this is, you can write here maybe, limit x tends to 0, 1 minus cos ax by x square is equal to a square divided by 2. Okay. Correct. So if this is a square by 2, now you can compare. What's the value of a? If you compare this with this, tell me, what's the value of a when you compare these two numbers? 1, correct? So this implies limit x tends to 0, 1 minus cos x by x square is equal to 1 by 2. And the answer is B. And this formula has to be noted. Okay. So anyhow, I'll give you a list of formulas for which you can evaluate the results either by using L'Hospital's rule or you can apply this 2L's rule and you can evaluate. Okay. So I am going to give you a few important results. So using that results, you will be able to solve these questions much more faster. Okay. So some important or some standard results maybe. These formulas could help you out some standard limits in answering the questions fastly. Okay, so you need not perform this complete analysis at every point of time, but if you learn few formulas which are easily derivable, then you can answer them. So first one, limit x tends to a, x power n minus a power n divided by x minus a. And what could be the answer for this? Can anyone tell me? I have covered all these things in my basic mathematics course, and you can go for the course if you don't know how I'm writing the formulas now. Okay, because every formula I have derived there. All the students who attended my previous classes, they know it. Please, sir, slow. Okay. N into a power n minus 1. Okay, so using this result, can you tell me one more limit? Limit x tends to a, x power m minus a power m divided by x power n minus a power n. Can you tell me, using this result, can you tell me what's the value of this? Please tell me what's the value of this, all of you. M by n into a power m minus n. Look, it's not a big issue. You can write 1 divided by x minus a in the numerator and also in the denominator. So the numerator part is m into a power m minus 1 and the denominator part will be n into a power n minus 1, which when you simplify, you will be getting this term here. Okay, next. Limit x tends to 0, 1 minus cos ax divided by x square. What is the value of this? Just now we have seen this is a square by 2. And what's the value? Okay, let me write one more limit. Limit x tends to 0, sine ax divided by x. Yeah, a square by 2 we have divided. Now please tell me what's the value of this? Limit x tends to 0, sine ax divided by x. It's a. Similarly, next. Limit x tends to infinity, sine x by x. In yesterday's class, you know this equation is the fees for this course, correct? So you know this is 0. Now for the people who don't know how this is 0, look, I'm giving you the explanation for this. It's a simple thing. Whatever you put in place of x, this sin x is always a finite value, correct? Because you know sin x always takes the values in between minus 1 and 1, correct? So whatever the value you put in place of x, this numerator is always lying in between minus 1 and 1. So which means this is nothing but a finite value in minus 1 comma 1 divided by infinity, and the answer is 0, correct? Because you know finite number divided by infinity will always give you 0. So there is nothing big in this to discuss, but one important thing you should make a note: whatever might be the value of x, this sin x is always finite. You should capture this point. Fine. So sixth one, limit x tends to 0, else let me write infinity maybe. Limit x tends to infinity, 1 plus a by x whole power x. You know what's the answer for this? Anyone? E, correct? E power a is the answer. Of course, when a is equal to 1, the answer is e. Yeah, of course. For all these points, you can prove using L'Hospital. Okay, all these 4 points you can prove using L'Hospital. And of course, this is a bit logical. So that's why I have given you this question. So you will be understanding this. And this is what we have. Okay. Similarly, limit x tends to 0, 1 plus ax whole power 1 by x. Can you tell me what's the value of this? Can you please tell me what's the value of this limit? It's again e power a. One time in GATE examination it was asked, but not in 2011. Before that, they have given something like this: limit x tends to a, 1 plus, limit x tends to infinity, I guess. Yeah. So let me erase this carefully. This eraser will be a bit new to me. Okay. So they have given something like this: limit x tends to infinity, 1 plus a by x whole power x is equal to, whole power x is equal to e power 7. This is what they have given. Then they have given limit x tends to a, x square minus 4 by something they have given, x minus 2, something like this. Okay. So if you know that a is equal to 7 from this equation, then you can substitute 7 here, and which means you can get the value of this expression. Okay. But if you know this, you will be saving your time in the examination to a while. Okay. Clear so far? Can I move for the next part? Please say yes or no. Yeah, both are same. Actually, these two results are same. And I have proved both these results in my basic maths course in the lecture 2. So you can go for the second lecture of basic calculus there. Okay, if you want to know how these things are getting valid. Next. How many points we have covered so far? 7 points. Okay. 8. Limit x tends to 0, a power x plus b power x by 2 whole power 1 by x. What's the answer for this? Can anyone tell me? I have proved even this. Can anyone tell me what's the answer for this? Square root of a into b. 9. Let us go one more step. Limit x tends to 0, a power x plus b power x plus c power x divided by 3 whole power 1 by x. Can you tell me what's the answer for this? Yeah, square root of AB is correct for the previous question. Now please tell me the answer for this. It's cube root of ABC. Okay. So similarly, if you have things like this, limit x tends to 0, 1 power x plus 2 power x plus 3 power x and so on plus n power x divided by n whole power 1 by x. If you have this, the answer for this is nth root of n factorial. Okay, and this result was asked in 1 year. Clear? Clear so far? Of course, it's a revision course, so I won't be having enough time to derive all these things again. But of course, whoever needs the derivations of this, I have already provided them in the basic course that we covered in summer. Okay, you can find the same course in the same channel. Okay, just wait, sir. Okay, I'll be waiting. Please, if you want to write something, you can. But soon, okay? Am I going too fast? How many of you are feeling that I'm going too fast? Please raise your hand in the chat box. Raise your hand in the chat box. How many of you are feeling that I'm going too fast? Me, okay? Rahul Sharma? No? We already watched your videos, so kindly do more problems, okay? It's perfect for revision. Yeah, I feel so because this pace has to be maintained. So see here. Okay, so yeah, better. So these are some standard 10 limits that I could give you so that you will be working out them at need. So we'll start solving problems. Okay. Yeah. Try to solve this question. This was asked in GATE 2014 ME. Please try to solve this question. Think. First of all, when you're substituting this value, what does this functional value getting converted to? You should think of that and then you should check for some procedures. So please try to answer this. Answer is D. Someone is saying it's B. It's 1 by 2 and again it's D, B. Okay, I think some voting is going on in between B and D. Let me check. Okay, so see here. I'm going to solve this. Limit x tends to 0, e power 2x minus 1 divided by sine 4x. I'll ask you one thing, try to tell me the answer. Limit x tends to 0, e power mx minus 1 divided by x. What could be the value of this? Please tell me. Try to solve this question and tell me the answer. What could be the value of this? Because if you substitute 0, you'll be getting 0 by 0 format here. Correct? So if you're getting 0 by 0 format, please tell me what's the answer for this? M. Correct? The answer for this is M, because you will be getting 0 by 0, and if you differentiate it once and if you substitute the limit, you will get M directly. Now, if I make small manipulation here, please check. What's the manipulation I'm making here? Limit x tends to 0, e power 2x minus 1 divided by x divided by sine 4x divided by x. Can I write it like this? So that if I cancel this x in both the denominators, I'll be getting the same question again. So if I'm getting this, I can write this as limit x tends to 0, e power 2x minus 1 divided by x divided by limit x tends to 0, sine 4x divided by x. And just now we have seen the limit of this format is M. So which means since here there is 2, the answer for the upper limit is 2, and for the lower limit we have seen the answer is 4. The answer is 1 by 2, which is mentioned as 0.5 here. Okay. Yeah, we can use L'Hospital rule as well, no issues. But yeah, okay, we can use L'Hospital rule, no issue. If you use L'Hospital also, you'll be getting. If you want, I'll show you. Just you can differentiate once. Yeah, I have uploaded engineering mathematics course. That's a comprehensive course, but there we don't have time for enough problems, so we put up a special series again for solving majority of the problems. Okay. Okay, Shiva, you want how to solve this question by L'Hospital? See here, limit x tends to 0. One thing is very much clear. This is giving you 0 by 0, correct? Because e power 0 is 1, 1 minus 1 will be giving you 0, and sine 0 is also 0. So you can apply L'Hospital rule. Yeah, let us apply L'Hospital rule here. E power 2x into 2 and differentiation of minus 1 is 0 divided by derivative of sine 4x is 4 into cos 4x. So if you substitute x is equal to 0 at any of these points, you will get 2 by 4. I mean at all of these points, This is 1 by 2. Okay, so both answers are same. You can match. Clear? So can I go ahead for the next question? Please say me. All of you, around more than 90 are on live. So please tell me, can I move for the next question? Okay. This is the next question. Please try to solve this. Please try to solve this question, all of you. Please solve this. Option A, 0. Okay, so let me see. Limit x tends to 0, x minus sin x divided by 1 minus cos x. This, of course, you know, this is 0 by 0 form, correct? If it is 0 by 0 form, you can apply L'Hospital. So let us apply. Differentiation of x is 1 minus derivative of sin x is cos x divided by differentiation of 1 is 0 minus differentiation of cos x is minus sin x. So this is equal to limit x tends to 0, 1 minus cos x divided by sin x. So if you apply L'Hospital again, you will be getting 0 as the answer. Correct? Is that okay to all of you? If you apply L'Hospital once more, you will be getting sin x by cos x. So you will be getting 0 by 1 and the answer will be 0. Clear? So this limit is 0. I am writing straight away. You can solve. If you apply L'Hospital once more, you will be getting limit x tends to 0, sin x divided by cos x, for which the value is 0 divided by 1 and the answer is 0. Clear? Please solve this question, all of you. And here I want to tell you one important thing before we solve this question. Anyhow, try to solve this question. Meanwhile, I'll be having some water because I'm continuously speaking for past, what's the time? Something around 10:47. 1 is the answer. Option C. Okay, it's option C. But whenever there is x tends to infinity, I just wanted to tell you one important thing here. So just please try this question meanwhile. Okay, so please see here. Let me tell you some important point before we solve these questions. See, limit x tends to infinity, a naught x power m plus a1 x power m minus 1 plus a2 x power m minus 2 and so on plus am plus f of x divided by b0 x power n plus b1 x power n minus 1 plus b2 x power n minus 2 plus and so on plus bn plus g of x, where, okay, let me write, is equal to a naught is equal to 0 if m less than n, is equal to a naught divided by b naught if m is equal to n, and this is equal to infinity if m is greater than n. And of course, to apply this, there is one condition: when both f of x and g of x, when both f of x and g of x are finite valued functions. Finite valued functions. And what are finite valued functions? See, for example, if you take sin x, whatever might be the value of x, your sin x always lies in between minus 1 to 1, correct? Which means the outcome of sin x is always finite. And similarly, if you take some other function like cos x, for example, it's also finite. So if you see this f of x and g of x, if they are finite valued functions, means whatever might be the input of x, if these two functions are giving you some finite value, then these conditions get pulled up. Okay, clear? how this is happening, I have already given in that course. So please, if you want, you can go there. I'm not going to give proof now. Okay, I have already given in that course. So if you see, this is the same case here. X is tending to infinity. This is a polynomial function of degree 1. This is also a polynomial of degree 1. And this sin x is a finite valued function. So what could be the answer? This both powers are equal. So m is equal to n. And here the coefficient is 1. And here also the coefficient is 1. So the answer for this limit x tends to infinity, 1 plus sin x divided by x is 1 by, x plus sin x. Let me modify this a bit. Yeah. X plus sin x is equal to 1 divided by 1, which is 1. Did you all understand how this is? Option C. Clear to all of you? Did you all understand how we are going? How this is 1? This class is till 12 a.m. today. Okay. And if you are sharp enough, you will finish before that. Okay. So see here. Then this is the question. This is actually a good sort of good question. So please try to answer this. Limit alpha tends to 0, x power alpha minus 1 divided by alpha. Be careful here, the variable is not x, it's alpha actually. Okay, so please make a note here, the variable is alpha but not x. To answer this question, if you want to apply L'Hospital, you need to know one thing. What is the derivative of a power x? You need to know this. Correct? If you want to answer this question, because if you put alpha is equal to 0 here, x power 0 is 1, 1 minus 1 will be 0, and this alpha is again 0, so we'll be getting 0 by 0 form here. So to apply L'Hospital, you need to know what's the derivative of this. And the differentiation of this is a power x into log a to the base e. Okay, clear? So if this is the case, this implies limit alpha tends to 0. See carefully. Here the variable is alpha. See, whenever the variable is x, I am differentiating with respect to x, and this is the result. And this a is treated as a constant. Similarly here the variable is alpha, and here x is treated as a constant. So if you see alpha tends to 0, the derivative of this x power alpha will be x power alpha into, what do we have? Log x to the base e minus 0 divided by 1. And if you put alpha is equal to 0 here, we have x into log x to the base e, and this is nothing but x into ln x, which is given here. And you know, log x to the base e can also be written as ln of x. Clear? Is that okay to all of you? And it was asked in civil engineering 2014. Okay, clear? Can I move ahead for the next question? Acha, x power 0. Sorry, I made a calculation error here. So please be careful with this. So if you put x is equal to 0, here this is 1 into log x to the base e, which means the answer is option A. It's not D. Sorry, it's A. Because we have a power alpha here, so when you are substituting the 0 here, x power 0 is going to give you 1. Okay, correct. A is the correct answer. Let us be careful with the calculations and substitutions here. This way. Is that fine? So can I move for the next question? All of you. I'm moving for the next question. I hope that's fine for now. Okay. This is the question. It was from GATE 2014, of course, and we didn't know something about branch. So what's the answer for this? What's the answer for this? C. Someone is typing E. Okay. E is given in option C. Fine. I thought you're typing option E, which is not here. Okay. So we have taught this limit. Limit x tends to infinity, 1 plus a by x whole power x as e power a. Right? E power a. Put a is equal to 1. Then what does this limit gets converted to? limit x tends to infinity, 1 plus 1 by x whole power x is equal to e power 1, which is e and which is situated in option C here. Okay. And I just want to tell you one more point. Please make sure if this comes in exam, please utilize this shortcut. If limit x tends to a, f of x power g of x, if this is of the form 1 power infinity, look, for any power, for infinity, power infinity, 0 power infinity, and 1 power infinity, we have two L rule, correct? One is apply log and then apply L'Hospital. But this, if this is a special case of 1 power infinity, then you can calculate this value in some other shorter way. Limit x tends to a, f of x power g of x is equal to, means the answer for this question is e power limit x tends to a, g of x into f of x minus 1. You can calculate this value, no issues. This value is the actual answer for this when we are getting 1 power infinity form. Okay, so if you want, you can try. For this, you will be getting the e again. For example, f of x is 1 plus 1 by x and g of x is x. This is what we have, correct? And that's how we are getting 1 power infinity. So if you calculate this value, this implies e power limit x tends to a, means x tends to infinity, g of x into f of x minus 1. So 1 plus 1 by x is f of x and minus 1 out of that will cancel this, and x into 1 by x will be 1, and this is e power limit x tends to infinity of a constant, which is e, because whenever there is a constant here, this application of this limit is not applicable, correct? This limit is not applicable when there is a constant inside. Okay, did you all understand this shorter way of calculating this limit whenever this is of the form 1 power infinity? I want all of you to respond. Please respond, because I can't see you, so please respond. Okay, so let's go for the next question. So before going for the next question, I want to ask you two good questions actually. First question, limit x tends to 0, 1 by x is how much? And second one, limit x tends to pi by 2, tan x is how much? These questions are not asked in GATE after 2011, but these two are really good questions. What is the answer for this? Matanaraj, Tamil. So see here, how is 1 power infinity is indeterminate form? If you say 1 square, I know I need to multiply 1 into 1. Then I will say 1. If you tell me 1 cube, I will multiply 3 times. And I will say 1. If you tell 1 power infinity, then my first question before writing this 1 here, I'll ask you how many times I should multiply. If you can tell this number correctly, we can tell the number correctly here. Okay. See here, both does not exist, because these two questions are really important and actually they are based on the definition of limit. See here, if you draw the graph of y is equal to 1 by x, for example, this is 0 and this is x, so this is minus x and this is y and this is minus y. So if you want to draw the graph of this y is equal to 1 by x, it looks something like this. Correct? This is the graph of y is equal to 1 by x. Now, if this limit want to be existing, then limit x tends to 0 minus 1 by x should be equal to limit x tends to 0 plus 1 by x. Correct? Means the left hand limit and the right hand limit should be same. But if you take this case, see what's happening here? In the left hand limit, means somewhere here, the functional value is going to minus infinity, which means this value is minus infinity. And if you talk about the right neighborhood of 0, which is here, and here the functional value is going to plus infinity. And if you see these two values are not finite at all, then we cannot compare them whether they are equal or not. Which means this is not equal, and And of course, you can't compare basically when you are putting infinities and all. So you can write here, they are not equal. So which means this limit does not exist. Okay, because I told you for the limit to exist, both left hand limit and right hand limit should agree with each other. But that's not happening in this case, correct? Because in the left neighborhood, the value is tending to minus infinity, and in the right neighborhood, the value is tending to plus infinity. So both these are not equal, and of course, the limit does not exist there. Clear? And similar is the case with tan x. So if you draw a graph for tan x, 0, x, y, and of course this is minus x and this is minus y. You know, suppose if you take x is equal to pi by 2 somewhere here, this is the line, then you know the graph of tan x looks something like this. Of course, this is again pi. This is pi by 2 and all. So if you see during the left neighborhood of pi by 2, somewhere here, the value is tending to plus infinity, and also in the right neighborhood of pi by 2, this tan x is tending to minus infinity. So these two are also not equal, and this limit does not exist. Did you all understand why both these limits does not exist? And these two limits were asked in many exams a lot of times, but not in GATE most frequently. Clear? Is that understandable to all of you? Okay, so can I proceed for the next questions? Yes, good. So see here, this is one question here. It's a numerical answer type question. So please tell me the answer for this. Limit x tends to 0 minus sin x divided by 2 sin x plus x into cos x. Please tell me what's the answer for this. It's a numerical answer type question, and I want answers from you. Minus 0.5. How come? Zero minus 0.33. Okay. So let us check the answer. What could be the answer? Limit x tends to 0 minus sin x divided by 2 into sin x plus x into cos x. So if you substitute this 0, straight away we'll be getting 0 by 0 form. No matter in that. Correct? So let us apply L'Hospital. Limit x tends to 0 minus differentiation of the sin x is cos x divided by 2 into derivative of the sin x is again cos x plus. Now when you have product of two functions, you know, if you have d by dx of f of x into g of x, means if you have product of two functions, then how come you differentiate this? First function into derivative of second function plus second function also derivative of first function into second function. So if you apply this, x into derivative of cos x is minus sin x plus cos x into derivative of x is 1. This is the value. So if you put x is equal to 0 here, now minus 1 divided by 2 into 1 plus this term, it's going to be 0, and this is plus 1. So plus 1 here, which is minus 1 by 3, and if you see minus 0.33 is the correct answer for this. Okay, minus 1 by 3. Yes, all of you are correct. Suhas, Mauli, Mahesh, Nagsai, Rahul, Deepa. Good. Raghunath. Please don't bother if I'm not reading other names, because in the chat only these are visible at this moment. Okay. So is that okay? Can I move ahead? Can I go for next question? Please say yes or no. Yeah, minus 1 by 3 is correct answer, and that's how we got minus 0.33. Yeah, this is the question. So please try to understand this carefully. So please try to answer this question. You know something? Actually, I have put answers for each and every question here at the bottom right corner of the slide. But you know, this which is here, moving off pages and all, has covered your answer, so that there won't be any chance for you for copying. Okay. If you want, you can check. See, here you can see something called ANS. For numerical answer type questions, it comes a bit left because I want to enter one number here, but it got blocked here, correct? And actually here, when I send you the PPT, I mean this PDF, you can see minus 0.33 will be there here. Fine. What's the answer? Option D, e power 2. Okay, so let me check. When x is tending to infinity, look, we need to talk a bit about this mod x, because this mod x is really some important this thing. So f of x is equal to mod x is something like this: minus x for x less than or equal to 0, x if x is greater than 0, which means if you want to calculate x tends to infinity, in the sense this x is a very big number, correct? Which means in that big number, this value will be 0 and modulus of 1 will be always 1. So this limit can be written as limit x tends to infinity 1 plus 1 by x whole for mod 2x can be written as limit x tends to infinity 1 plus 1 by x whole power 2x, because this value which is inside this modulus is always positive, because this x is very big, which means this value is very small. So even if it's positive or negative, this total value won't be negative. Clear so far? So the answer for this is e square, which you already know here. Okay. Solve this question. It's a good question actually. Yeah, because it's positive in the previous question. So please try to answer this. And please subscribe to the Telegram link that's coming continuously here, because we'll be uploading all these notes in the Telegram channel only. Okay. And the link for the Telegram channel will be provided at the end of this lecture. So what's the answer for this? C, option 1. I mean, answer is 1. So option is C. That's what you're telling. So let me check. This is of the form infinity power 0. So let me apply the 2 L's. Okay. First, let y is equal to x power 1 by x. This implies ln y is equal to ln x power 1 by x. And this implies y is equal to 1 by x into ln x. This is what you have. So you applied log. Now next apply limit on both sides. Limit x tends to infinity ln y is equal to limit x tends to infinity. Limit x tends to infinity. What is on the right? 1 by x into ln x. So this implies, look, this limit is a mathematical operator. So it doesn't matter if you apply ln and then limit, or if you apply limit and then ln. So let us write this as ln of limit x tends to infinity y. This is equal to, now see carefully. If you substitute infinity here, log infinity is infinity. And also if you substitute x is equal to infinity in the denominator, it's giving infinity by infinity form, which means you can go for L'Hospital. So this is limit x tends to infinity log x by x, and this is of the form infinity by infinity. So now apply L'Hospital. This is limit x tends to infinity, derivative of log x is 1 by x, and derivative of x is 1, and this will be 0 when x is tending to infinity. So this means this limit x tends to y, I mean x tends to infinity y is equal to e power 0, which is 1. And what is y? This what you have assumed here. And this question has been asked many times, but I could solve only once here. Answer is C for this. Okay. You need to apply a log and a L'Hospital. That's it. Yeah, Vanju, this class is daily in this time, 10 p.m. to 12 a.m. Okay. So can I move ahead for the next question, all of you? Please respond. Can we move for the next question? Yes. This is the question. Try to solve something. Solution. Limit x tends to infinity 1 plus x square whole power e power minus x. Please try to solve this. It's of infinity power 0 form again. how to ask doubts. If you have anything, you can ask here, chat box. I'm live. And daily we'll be meeting till December 31st. So you can ask at any time, no problem. I'll be most happy to answer you. C is the answer, option 1. I mean, this one. Side please. Okay, you want me to throw out of the board? Huh? Option A. Okay, and some other have opted for C. Divya, you are getting C again. Umesh, C. Okay, so let me check what's the correct answer. So if you see, this is giving the form infinity power 0. Correct? Because when x is a big number, then you know x square is still more big number, and e power minus infinity is tending to 0. So this is of this form. So if you are getting infinity power 0, let us apply this. Y is equal to limit x tends to infinity 1 plus x square whole power e power minus x. I mean, sorry, this limit won't be present here for the time being. Y is equal to 1 plus x square operating on e power minus x. I mean, to the power e power minus x. So let us apply our first L, which is log. Ln y is equal to, if you apply logarithm, I am not writing elaboratedly, e power minus x into ln 1 plus x square. This is what you will be getting. And this implies ln y is equal to ln of 1 plus x square divided by e power x. So let us apply limit. Limit x tends to infinity, ln y is equal to limit x tends to infinity ln of 1 plus x square divided by e power x, and this value is infinity by infinity now. So you can apply L'Hospital at this point of problem. So limit x tends to infinity, or let me write ln of limit x tends to infinity. I told you logarithm and this limit are just operators, so you can interchange them, no issues. This is equal to, if you apply L'Hospital rule here, limit x tends to infinity, derivative of log of 1 by x square, 1 by 1 plus x square into 2x divided by e power x. Differentiation of e power x is e power x itself. So this implies ln of limit x tends to infinity y is equal to, look carefully, this is the most important step at this point. If you are applying x tends to infinity, this limit is something like limit x tends to infinity 2x divided by x square plus 1. Can you tell me what could be the answer for this limit? See, both are polynomial functions, and if you see, the power or the degree of numerator is less than the degree of denominator. So can you please tell me what could be the answer for this? I told you, no, a power x power m, x power n, and when m is less than n, the answer, it is, no, it's not 2. See, here the power is only 1, but here the power is 2, which means denominator has highest power. So the answer is 0. And 0 divided by infinity, what could be the answer? For this complete limit, what could be the answer? 0. It is 0 as per this, and this denominator is infinity, and you know 0 by a very big number is always 0. So this implies limit x tends to infinity y, which is, and y is actually this term which we have taken, is 1. The answer is C. Rahul, please ask me, what's your doubt? Yeah, I'll tell you textbooks for mathematics and questions and all. Please don't worry about that. One into 2. No, see here. I told you if m is less than n, answer is 0. Correct? So if you see here, the numerator is a linear polynomial, means the degree is 1. Highest degree is 1. So m value is 1. And in the denominator, the highest value is 2. And this is 2. So 1 is less than 2. The answer for this limit is 0. Okay. The ratio of constants 2 by 1 is only valid when both are of same powers. Okay. But numerator is having lesser power here. Okay. So we are going for the next question. This. Please try to solve this, all of you. If you are putting 0, I think you are getting 0 by 0 form, correct? So you can apply L'Hospital directly. Please try to apply and tell me the answer. C is the answer, 4 by 3. C. Okay, all of you are getting C. So let me check. Limit x tends to 0, log of 1 plus 4x to the base e divided by e power 3x minus 1. And if you see, this will be giving you 0 by 0 undoubtedly if you substitute, because log 1 is 0 and this e power 3x minus 1 is also 0. So let us apply L'Hospital rule. So if you apply L'Hospital rule, differentiation of log of something is 1 by that something into the inner derivative of this function is 4 divided by differentiation of this. Differentiation of e power 3x is e power 3x into 3 and differentiation of 1 is 0. So this value is nothing but 4 by 3 if you substitute x is equal to 0 in this equation. I mean in this function basically. Okay. Because if you put x is equal to 0, this term is 0. So 1 by 1 is 1 into 4 is 4. And if you put x is equal to 0 here, this 3 into 0 is 0 and e power 0 is 1. So 1 into 3 is 3 and it's 4 by 3, which is option C here. Clear? So can I go for the next question? All of you? Please tell me, can I go for the next question? Yes? I want responses from all of you. Okay, if you, or else if you're not understanding, please talk to me. One of these two things should happen continuously. Okay. This is the question. Please try to answer. In the PDFs, in Telegram, most of the PDFs are asking for passwords. How can we know that? Acha, I'll talk to the people, but I hope we'll be uploading these files without any passwords. Okay. And thing is, you should all subscribe to that, because we'll be getting the notes only if you subscribe to the Telegram channel, because that's a common channel where we'll upload all our material. Okay. Answer is C for this. I think C should be the correct answer. C. If you have things like this, by looking at this, something that comes into our mind, we should rationalize this, correct? So solution, let us try to solve this. Limit x tends to infinity, square root of x square plus x minus 1 minus x divided by, if you want to rationalize this now, into root of x square plus x minus 1 plus x divided by square root of x square plus x minus 1 plus x. So let us multiply both the terms in the numerator. So okay, 1 maybe. Limit x tends to infinity. Now this is of the form a minus b into a plus b. So this is of the form a square minus b square. So a square minus b square divided by root of x square plus x minus 1 plus x. And this x square gets cancelled. And if you see here, limit x tends to infinity, you have x minus 1 divided by, from this term, see carefully, can you take x square common from this complete square root? From every term which is here, can you take x square common? Yes or no? Please tell me, can we take x square common here in each and every term? Yes. If you take x square common, look, when you are taking x square common, and if you want to bring that x square out of the square root, can I write x here into root of 1 plus 1 by x minus 1 by x square? Can I write this for this square root? Can I write this for this square root? Yes. Plus 1 if I take this as common. Now, similarly, if I take 1x common in the numerator also, x into 1 minus 1 by x. This is what you can. You can cancel this x and x. Now, tell me one thing. As x tends to infinity, this implies 1 by x tends to how much? When x is tending to infinity, what does 1 by x tends to? Means I am telling you that x is very big. If x is very big, this 1 by x will tend to 0. And if you see, if you substitute 1 by x is equal to 0 at all places, you will be getting 1 by 1 plus 1, which is 1 by 2, which is there in option C here. Correct? Because if x is tending to infinity, then this 1 by x will tend to 0, this 1 by x will tend to 0, this 1 by x whole square will also tend to 0. Okay. So that's how the answer is 1 divided by square root of 1 is 1 plus 1. This is the expression. Clear? Can I go for next question? Please say yes or no. Can I go for next questions? Yeah. This is a numerical answer type question, and see, I have kindly given answer also here, but it got blocked. So please try to answer this question, all of you. Better now. I think you can see the question. Thank you, URP. Victor, where are you from? You want graph for sine 2x minus 5. See here. If you want to try to plot the graph of this, look. You know one thing, minus 1 less than or equal to sine 2x less than or equal to 1. Correct? You know this. Next. You need to subtract minus 5 from this. So, minus 1 minus 5 is minus 6 less than or equal to sine 2x less than or equal to 1 minus 5 is minus 4, which means we can write, yeah, of course, this is the equation. So if you want to, of course, here it's minus 5, sorry, minus 5 less than or equal to minus 4. So first of all, plot the lines y is equal to minus 6 and y is equal to minus 4. Y is equal to minus 6 is something here, and y is equal to minus 4 is somewhere here. Now, you know at x is equal to 0, the value is minus 5. And from here, if x increases for a while, this sin x increases. So you can plot the sin x here, something like this. Okay. The graph will lie always between these two lines, because you see this function is lying always between these two lines. If you remember, Kamaluddin and few of the students who attended the first lecture, I told you how to draw a graph for any function. You remember this? I told you what are the certain procedures to be followed for drawing graph of any function, and I have drawn you graphs of sin x by x, x into sin x and all. Do you remember this? Many of you who attended my first classes, they can see this. I have taught this part also. So whoever didn't see, if you have time, you can please go through that. But of course, if gate is short and if there is no time, you better follow these classes and accept what I am telling, because I generally speak truth. Okay, so you can trust me. So what's the answer for this? Meanwhile, we are talking about some graph. Meanwhile, it's okay. Answer is 0.5. Okay, let me check. So limit n tends to infinity. Again, if you rationalize, you will be getting n square plus n minus n square plus 1 divided by root of n square plus n plus root of n square plus 1. This is what you will be getting. N square gets cancelled. So limit n tends to infinity. N, if you take common, you will be getting 1 minus 1 by n divided by, here n, if you take common, you will be getting root of 1 plus 1 by n plus root of 1 plus 1 by n. I think here squares should come. Yeah. N gets cancelled. So if you put 1 by n is equal to 0, you'll get 1 by 2 again. 0.5. Clear? It's just about rationalizing and taking things common. I'm not spending much time on this, okay? Because this is hardly of 8th or 9th standards. It's okay. So you can work out. Basically, here the art lies in simplifying this expression. Okay, and then it comes to a bit higher thinking that when n tends to infinity, this 1 by n tends to zeros. Clear? You want me to take ESC questions also? I can take, but then problems number get increased. Then we can't meet the schedule on time actually. Okay, but anyhow, ESC questions are a bit calculations involved. Of course, calculator is not permitted. I understand. Anyhow, we'll try depending upon the time. Okay, at least for a few topics. Next, this is the question. Please try to solve this. Please solve this question. It's a very easy question. I hope you can solve this very easily. Okay, few good questions on ESC at least. Okay, sure. From the very near topics. What's the answer for this? Two. Option D. See here. You have one theorem which is called sandwich theorem. You know what does it tells you? If A less than B less than C and A is equal to C, means if these two are equal, then definitely this should be equal to A or C since both are equal. Okay, so this is the, see for example, if I tell you something like -1 less than or equal to f of x less than or equal to minus, or else let us remove this negativity here, less than or equal to 1. If I tell you this, means whenever you are plotting your f of x, 0, x, minus x, this is y and this is minus y. So whenever you are plotting this f of x, if I am telling you it can't go below 1 or it can't go above 1, then which means for every x you should get your points on this line itself, which means this f of x should also be equal to this value. So let us apply limit for this inequality. Limit x tends to 0, 2 minus x square by 3 less than limit x tends to 0, limit x tends to 0, x into sin x divided by 1 minus cos x is less than limit x tends to 0, 2. So you can apply limit for all the three steps in the inequality. And the answer for this is, if you put x is equal to 0, 2, less than limit x tends to 0, x into sin x divided by 1 minus cos x less than 2. So if you see these two are matching, which means this limit should be equal to 2, and this is what they have exactly asked. What is the value of limit x tends to 0, x into sin x divided by 1 minus cos x? Answer is 2. Okay, clear? So the answer is 2 for this. Please try to answer this. The value of the expression limit x tends to pi by 2 mod of tan x by 2. And of course, if you want, you can remove this 2 outside because that's just a constant. So 1 by 2 into limit x tends to pi by 2. Yeah, but directly applying Helhospital will take a bit of time, Kamaluddin. Okay, so that's why. The inequality is given to save time. What could be the answer for this? A. Correct? Because see, previously you have seen when x is equal to pi by 2, x, y, and of course this is minus y and this is minus x. So you have seen the graph of tan x is looking something like this here, and it's going somewhere here. But now if you are having this modulus, which means the negative values of tan are eliminated, and this graph, instead of going it this way, the graph takes some different shape. Let us see what is that different shape. Something like this, and both the peaks go for plus infinity at that instant. Okay, and the answer is infinity, because a very big number divided by 2 is still a very big number. See, infinity is not a number, first of all. Okay, infinity is a symbol to denote a very big number. Clear? Yeah, basically if modulus is given, your function graph changes, correct? This is how it looks like for mod tan x. See, basically the graph is something like, it should be something like this. But now since there is modulus, whatever the negative value is present here, it gets converted to positive. Means this graph which is here is a reflection of this. Acha, this is eraser, okay. Okay, so can I go for the next question? What's the time, by the way? Yeah, I'll share the PDF, no issues. You can find the links in the Telegram channel. Okay, so yeah, what's your doubt, Chala Siskian? Please ask, what's your doubt? So please tell me. Siskian, okay, fine. If you have some doubt, you can maybe contact me in some other source. Let us move forward. What's the answer for this? Do I need to solve this question anyway? (0.25). B 1/4. So see here. First of all, this is of second degree and this is also of second degree, correct? Which means for both the polynomials in numerator and denominator, this degree is same. So if degrees are same, here it is 1 and here it is 4. So answer is 1/4. For limit extends to infinity and all. Did you all understand why it's 1/4? Because I told you this limit condition. You remember this? Limit extends to infinity, a0 x power m plus a1 x power m minus 1 and so on plus am divided by b0 x power n plus b1 x power n minus 1 plus and so on plus bn is equal to m by n if is equal to a0 by b0 if m is equal to n. This is what I told you, and here this is the case. This is not one, sorry, I think some shortage of space here. If m is equal to n, okay, better. Is that okay to all of you? Yeah, you can take x square common. That's gives the same thing actually. You know, if you look at the proof of these conditions, what I have given you, I was taking the highest power of x common in both numerator and denominator and then simplifying the things. Okay, so there's no issue. Please solve this. If you see, the numerator power is 9x square and there is a square root, which means if you take one x square common, this can be written as 9 plus 20 divided by x square divided by x. If you take common, 1 plus 7 by x. X gets cancelled, of course, and this is equal to, sorry, this is infinity. So limit x tends to infinity, root of 9 plus, you can write this something like root of 2020 divided by x whole square, maybe, divided by 1 plus 7 by x. And you know, when x is tending to infinity, this some constant number or some finite number divided by x will give you 0, and this answer is 3 by 1, which is 3 again, which is an option C here. Clear? Is that fine? Yeah, answer is 3. This is one question that was asked in GATE 2020. Pawan Kalyan, I think Negi sir didn't leave an academy. Okay, he's still there. D is the answer or C? C? Okay, so let me solve this. See here. Look, this question was asked in mechanical engineering, and there is one particular reason, you know, to give this question in mechanical. I'll tell you why. First of all, let us solve, look this question as a limit and let us solve this as a limit. So if you put x is equal to 1, this will be 0. So e power 0 will be 1. So 1 minus 1 will be 0. Same is the case with denominator. So you'll be getting 0 by 0 form. So let us show you. 1 minus e power minus c into 1 minus x divided by 1 minus x into e power minus c into 1 minus x. This will give you 0 by 0 form. Correct? Because if you put x is equal to 1 here, then e power 0 is 1, and this 1 minus 1 will give you 0, and same is the case here, we will be getting 0. So let us apply L'Hospital rule. This is equal to limit x tends to 1. If you apply L'Hospital rule, the differentiation of this one is 0 minus differentiation of this is e power minus c into 1 minus x into the inner derivative of this function. So differentiation of cx will become c here, divided by, same with the denominator, 0 minus first function into derivative of second function, which is this. So c into e power minus c into 1 minus x into, plus second function into derivative of first function. So this is what we have, because differentiation of this first function is 1. So let us write these terms together. Limit x tends to 0 minus c into e power minus c into 1 minus x divided by, in the denominator both these terms contains e power minus c into 1 minus x. So let us take that common, e power minus c into 1 minus x, and of course there's a minus sign here, so let us use that minus sign here. Here we have x multiplication with c, so cx plus 1, and you can cancel these two terms and this minus sign here. So if you cancel these two terms, we have limit x tends to 0, c by cx plus 1, and if you put x is equal to 0, you'll be getting c by c plus 1, which is in option C. So the answer is C. Okay. You need to be a bit careful while finding the derivatives and taking the terms common and cancelling them. Okay. If you are careful at that moment, then things are fine. X tends to 1. Yeah, sorry. X tends to 1. Now, just I want to spend 1 minute for mechanical people, because this question was asked in 2020 ME. So I just want to spend one small time for you. Have you seen this formula anywhere? Have you seen this formula anywhere? Where, of course, NTU is equal to overall heat transfer coefficient into area by Cmin. Have you seen this formula anywhere? Heat transfer, correct? And what is this? Effectiveness of parallel flow or counter flow? Please tell me. It's a effectiveness of counter flow heat exchanger. And if you see, when the C is equal to 1, this becomes 0 by 0, and you will be writing effectiveness is equal to NTU by 1 plus NTU. You remember this formula? Number of transfer units for counter flow heat exchanger effectiveness formulation. Correct? You remember this? This was exactly asked here. And that's why this question was given in mechanical. If you know that this formula resembles a counter flow heat exchanger effectiveness when x is tending to 1, without solving all these things, you can put away the answer NTU by 1 plus NTU. Clear? So that's why it was mentioned there. Anyhow, that this part you need not bother. Sorry, not this part. This part all others need not bother, since the question was given in mechanical. I thought of discussing a bit for my branch mates. Okay. So this question is from XE 2015. So please try to solve this. You know it, when both heat capacity rates are equal of both hot and cold fluids, then your effectiveness is number of transfer units divided by 1 plus NTU. I think your heat transfer faculty might deal that anyhow for mechanical. The value of the following limit. B. What is B? I am blocking something. 1. It's either D or B. Acha. It's not 0 or infinity. Okay. So many people are opting for B. Let us see why it's B. First of all, limit extends to infinity. This limit can be C. Limit is a mathematical operator and it can be split at all plus minus multiplications. Okay. X tends to infinity. X minus sin x divided by x plus sin x plus limit x tends to infinity log x to the base e divided by x. So what's the value of this limit? Please tell me, all of you. What's the value of this limit? 1. Correct? Because both the degrees are 1. So the ratio of their coefficients 1 by 1 is 1. Now you need to find this. This is, let us write it separately. Limit x tends to infinity ln x by x, and this is of the form infinity by infinity. So this is equal to limit x tends to infinity. If you are applying the L'Hospital rule, you will be getting 1 by x by 1, and this value is 0, which means this limit here, it is 0. And what's the value of 1 plus 0? It is 1. Clear? Is that okay to all of you? Okay. Okay. Meanwhile, so let me write something. What's the time, by the way? 11:45. We are left with 15 more minutes. Good. So we'll talk few good things here. Look, whenever you are trying to attempt GATE examination, you have basically two domains, and of course we talk them as three. One is general aptitude and technical section. And this technical section includes maths and core subjects, whatever you have. Now, if you score 1 mark in general aptitude or in mathematics or in core subjects, it's equivalent. They don't show that variation. Okay, so that's why I'm telling you all these three are really important. But if you have a strong background of this, I'm not telling this because I'm teaching mathematics. Okay, I teach even thermal subjects for mechanical. So I'm telling you this math is really important because knowing this will help you in this to a lot extent. Okay, and you know, in general aptitude last year, if you look at GATE question papers of last year, few questions from maths were asked in general aptitude. For example, they asked some things like integral 0 to 4 integer part x dx, all these questions. Is this a general aptitude question generally? Please tell me. Is this question, does it belong to general aptitude? Because you need to know what is this function, integer part function. But this question was asked in general aptitude section last year. And you know, few more questions like 8 plus 88 plus 888, you know, this kind of questions were, and so on, plus 888 and so on, n times. These kind of questions, you know, you need to have some strong background of basics of mathematics at least. Okay, so that you'll be able to answer all these questions. To be honest, they are telling you 13 to 15, but generally this part will help you more than this. Okay, in GATE examination. So please, you know, try to get acquainted with the things. And am I going too fast? But I think this should be the pace to cover this syllabus within this time. Okay, good pace, correct? Please sir, slow. Okay, and I'm telling you one important thing. Whoever is facing a bit difficulty here, you know, you try to look at that maths course as well, because total there are 46 videos. Yeah, I'll talk about MSQs and all. See, total there are 46 videos of that, you know, 46 lectures of the basic mathematics course which I dealt in the summer. Okay, so daily when I'm dealing a subtopic, if you look at one lecture within this 45 days, this complete course gets covered and also this course gets covered, which means you'll be having a strong background of mathematics finally. Okay, because if you want to sit and study all the 46 videos at a single stretch, no, it's not possible 100%, and you won't be feeling good to do so. So the main important thing that you should do is, whenever I'm teaching this topic, please try to watch one video from here, and by the time this course gets finished within 45 days, your all videos gets finished here and also here, which means things will get clear. Yeah, I'll complete mathematics. See, in yesterday's event, who didn't attend this launch event, I have given one QR code for the complete schedule. Okay, and that PPT has already uploaded in the Telegram channel of us. You want some information of step function? I'll give you. See here. Step function, or you can call it as greatest integer function, or sorry, integer part function. Integer part function. And how do we define this? Yeah, we'll talk about this lecture is not yet done. I just wanted to give this. This function is defined as x for all. Okay, let me erase this x here. Let me write n for all x less than or equal to n less than x plus 1. Means if there is any real number, sorry, yeah, x less than or equal to n less than or equal to x plus 1, correct? So basically, what's the function? See here. Let us make a bit correction here. Let us put this n here and let us write this n less than or equal to x less than or equal to, I mean not equal to n plus 1. Yeah. If you see, I didn't put the equality sign here. Okay, there is no equality here. There is only less than sign, which means how does the graph look like? See, I have already given this graph in my previous course. So let us try to read all this again. 0, 1, 2, 3. I am showing only for the part that is close to origin. -2. Okay, and here if you have 1, 2, 3 and all, and of course this is y-axis, x-axis origin -x, and if this is -y. Okay, so now look, how does the integer part x looks like? See, this lecture is not yet done. We have few contact sharing and also few details about the course, so please wait. So if you see, if I write integer part of 3.56, what could be the answer you will be getting from this definition? Look, this 3.56 lies in between 3 and 4. So if integer part x is equal to n for all real numbers which are lying in between n and n plus 1, including n, what could be the answer for this? All of you. It is 3. Similarly, for all values between 0 and 1, the value is 0. For all values between 1 and 2, the value is 1. Actually, I should not touch this line here. 0 to, oh, sorry. 1. It should not get touched to 1 because I didn't put the equality sign here. Similarly, for 1 to 2, you have this. Similarly, for 2 to 3, like this. From -1 to -1, this. So this is how the graph gets generated, and of course I have given a more descriptive analysis of this function in the previous course. So you can see this is how the integer part x function looks like. Okay, and of course we'll be solving few questions on integer part x function in tomorrow's class. And if you see, this is the contact that is available to us to contact us. And one thing, in the schedule we have given something called cumulative session, correct? After every 4 lectures, or if the course is getting, if a particular topic is getting completed in 5 lectures, we'll be having one cumulative session. Here we'll be solving subtopic wise. In the cumulative, we'll be solving the questions on complete topic. So I am restoring, I am putting hold for some questions to solve in the cumulative sessions. Okay, so don't feel questions from TPD didn't come or questions from ECE didn't come and all. We'll have all the questions getting solved here. Okay, so these are 2 channels, mechanical and for ECE, that yesterday I gave you. If you are from mechanical, you can scan this code, and if you are from rest others, you can scan this code, and we'll be supplying the same data in both the groups, no issues. Okay, just to avoid the rush in the groups, we have given 2 different groups, and this is our website. You can always visit us at this website, engineershub.com, where you will get to know of Engineers Hub and all. And of course, these are Telegram links exclusively designed for sharing content and all. And of course, few of you have asked for this landline number, so we have provided that here. So you can ping to any one of these numbers, and you can get the details about upcoming batches or what are the facilities available for you. And anyhow, if you want to come offline and meet us, definitely you are always welcome. And this is the location. The institute is located in Visakhapatnam in Daba Gardens, where you can copy paste this address at some point and you can reach us. Okay, so this class. Yeah, this class will be there in the YouTube channel of Engineers Hub. So you can always go for the Engineers Hub channel to watch any of the video that comes streaming on behalf of Engineers Hub. Okay, so yeah, we'll have class daily from 10 PM to 12 AM. So we'll be covering one subtopic, and by that December 31st, we'll be completing the whole syllabus. Clear? कल क्लास टाइमिंग सेम 10 बजे से 11 बजे तक. No, I can't start class a bit early because other classes are scheduled before. Okay, so that's from my side for today. So we'll meet tomorrow at 10 o'clock, and please like the video and share it, because we are offering this course for free, and during this time it's of great use for all the aspirants. See, total 8 lakh aspirants have been applied, and if you could help at least 1%, 8,000 people, it could be of great use. Okay, so please like the video, and you can write your comments in the comments of this video. Okay, so thank you all, have a nice day. Yeah, thank you.